Okay, here's our video for the operations of functions notes. I want to start by reviewing function notation. So if you just rotate your note sheet this way to the left 90 degrees, we are going to write some notes along the side here. So this is just a little function notation review. So I want to start by showing you an equation. So y equals 3x squared minus 5. This is a lovely equation. This is the equation in function notation. Where f is the name of the function and x is the independent variable. So sometimes we use the function notation f of x and y interchangeably sometimes. Then this right here, if I switch from f of x to f of 4, this is telling me that x now equals 4, and I'm going to substitute 4 for every x that I see in my equation. We're going to plug it in and then simplify, and that's called evaluating a function, finding the value at a particular input or 4. So I'm going to plug 4 in for my x, follow my order of operations. So I'm going to do exponents first. 4 squared is 16. Multiplication next. 3 times 16 is 48. And then I have 43. So we would say here, or we could say that f of 4 equals 43. 43 is the y value when the x value is 4. That's one great thing about function notation is you can automatically see the ordered pair, the two numbers that go together, just from the way you write your final answer. All right, so keeping all that in mind, we are going to talk about operations of functions. So that means add, subtract, multiply, and divide. And up here we have, or I guess one thing I wanted to say, let me go back this way. When we use this word notation, it means the symbols that we are using to denote or imply or express something that we're doing. So this does not mean f times x, although it kind of looks like f is a variable, x is a variable, and they're being multiplied. It's our job to understand in the context of the situation that it doesn't mean that this is function notation and that f is just the name of the function and f is my independent variable. Now, when we go on to add or subtract multiple functions, one, they will have different names, which means they will have different letters. So we might have f of x, g of x, h of x, something like that. And that's what's happening in this table here. This is showing me two different notations or symbols that I can use to show that I am trying to take the sum or add two different functions f and g. I can write f plus g inside the first set of parentheses and then of x, or I can split them up and write f of x plus g of x. They mean the same thing. And the same is going to be true for subtracting, multiplying, dividing. I can write f minus g in the first set of parentheses, or I can split up the function notations and write minus in between them. Same for multiply, same for divide. And then here when it adds on that g of x cannot be 0, that's because if you're dividing by g, you can't divide by 0, so it's a qualification right there. Okay, so for these examples here, we're just going to practice doing operations on these two functions. We're being given f, which is x plus 3, and g, which is 2x minus 4. Notice they both have the same independent variable. So I'm going to do f plus g of x first, f minus g of x second. So here's the first one. I'm going to take f. So this notation is the same as saying f of x plus g of x. So I'm just literally going to do that. F of x is x plus 3 plus g of x, which is 2x minus 4. I just need to combine like terms, the x's and the integers, and it is 3x minus 1. Now I'm going to subtract f of x minus g of x. So f of x is x plus 3 minus g of x, which is 2x minus 4. Now, when adding, putting parentheses around the second function maybe wasn't such a big deal, but in this case it does serve a bigger purpose. We need to remember that we are subtracting both terms on this binomial. So that's going to distribute, that's going to distribute. So it'll be x and negative 2x makes negative x. And then 3 and now positive 4, because negative 4 makes positive 4. So plus 7. And then down here we are going to multiply and divide them. So for multiplying, f of x is x plus 3 times 2x minus 4. And here the parentheses are also important because we have a binomial times a binomial. This is going to be you can do FOIL, you can do box method, you can think about it as double distributive property, whatever you like. But you're going to start by doing x times both of these terms. So x times 2x, x times negative 4. Then you're going to take the 3 and distribute it. So 3 times 2x and 3 times negative 4. Combine your like terms. And you are done. And for the division, we have f of x over g of x. So x plus 3 over 2x minus 4. Normally when you have a fraction, you're going to try and simplify. For example, if you have 3 over 6 with just integer fraction, you simplify by dividing out their common factor and you get 1 over 2. So even with algebraic expressions or other polynomials, you still want to try and divide out a common factor. In this particular situation, we don't have any common factors. So this would be my final answer. I'm not stressing, that the denominator can't be 0, but just as an aside, the denominator would equal 0 if x was equal to 2. So we do have this domain restriction, but we're not really focusing on that right now. So that's just extra information for you. I do want to say something about simplifying when you have x's. This is going to be one of the most common mistakes that I see. I'm going to put this in a different color so you know it's not part of the math, but here's something you cannot do right now. You cannot say, well, I see an x on the top and bottom, and I'm going to cancel them right here. Okay? We don't cancel things that are being added or subtracted with other things. We only cancel factors, which are things that are being multiplied by other things. And we can, so I want you to just remember okay, sorry, I'm trying to think 5 different ways to say what I'm trying to say, and I can't pick one. So the x's don't cancel because they are terms, not factors. So here's where you could cancel x's. If I had something like this, these x's are only being multiplied by other things, so they are free to be canceled. And just like 2 over 6, really when we're canceling, we're saying 2 is 2 times 1, 6 is 2 times 3. We're canceling the 2, the common factor, and we're getting 1/3. You could cancel in this situation that we had, if I had x plus 3 grouped together, and I had another x plus 3 group on the bottom. In this case, the group themselves is being multiplied by something else. So now the group is a factor. Inside the group, I have 2 terms being added to each other. The group itself is a factor being multiplied by other things. So the group here could be canceled. So I just want to make sure I mention that to you. All right, on the back, we have a situation where we are going to be writing functions in function notation and then combining them. So I want you to take a moment and read the situation, and I want you to take a moment and read through all of these problems if you haven't already. And I want you to try them by yourself. Try to come up with an equation for each one, and only then come back to the video. I am going to talk through each one, but I want your brain to have the opportunity to try it out first. And then when I go through, it'll make more sense to you. So pause your video now and try these problems. All right, so we have this situation. You receive a coupon for $5 off a pair of jeans. When you arrive at the store, you find all jeans are already 25% off. Let x represent the original cost of jeans. So we want to write a function f of x that represents the coupon. So you should have f of x equals x minus 5. Then we want to write a function g of x that represents the effect of the 25% discount. Now, there's different ways to get here. Here's my final equation. G of x equals 0.75x. Okay, or maybe you wrote 1 minus 0.25 times x. 1 means 100%, 0.25 means 25%. Remember that the percent means per 100. And we don't do math on the percent, we convert it to a decimal first by dividing by 100, so per 100. And so that's 25% is 20.25 as a decimal, 100% is 1. So if you're subtracting off the 25% discount, you end up paying 75% of the total cost. So this is my function that I'll be using. Now we want a function that represents how much you would pay if you use the mail coupon first, followed by applying the discount. So my equation looks like this. And I've written it specifically with the x minus 5 in parentheses because if I'm following my order of operations, the parentheses means, hey, do this first. So I'm applying my coupon first, getting that number, and then multiplying it by the 0.75. J of x is the opposite situation. We're taking 75% of the cost first and then subtracting the 5. You don't necessarily have to put a multiplication in parentheses. I just did to be consistent with the above function. And now number 5. You find a pair of jeans for $36. How much would you have to pay if the discount is applied first and then you use your coupon? So the function that did the discount first and then the coupon was the equation from number 4. So that means we're going to evaluate J for 36. X is now 36. So I'm going to plug it in and then do the math. 0.75 times 36 is 27. Minus 5 is 22. And then in number 6, we're doing the opposite situation. So we're doing the equation from number 3, the H function, where we did the cost minus 5 first. So 36 minus 5. So that is 31. And that is 23.25. And so the answer to the last question, which is a better deal, the better deal is store discount first, mail coupon second.